Now, we will compare the mechanical and electrical oscillators, that is analogy between mechanical and electrical oscillator. So, what is analogy? That is what is symmetry. If we compare the mechanical and electrical oscillators, we will find the same type of results. In mechanical oscillator, the equation is d square x upon dt square plus omega square x is equal to 0, and in electrical oscillator this equation is d square q upon dt square plus omega square q is equal to 0. So, from these equations it is very much clear that x is analogous to q, means x, that is displacement, and in electrical oscillator this x may be written as q. Q means charge. If we find its derivative, then its derivative is velocity dx by dt. This is velocity of mechanical oscillator, and if we take the derivative of this charge dq by dt, then it is current I. So, we can say that this velocity is analogous to electric current, as displacement is analogous to charge. And also, if we take again derivative of this x, that is double derivative d square x upon dt square, it is acceleration. Or in this case, d square q upon dt square, it is nothing, it is rate of change of current, because it has no any special formula. So, we may write this dq by dt as I, and d square q by dt square is equal to di upon dt, that is rate of change of current with time. If we compare the values for these omega squares, so we know that omega square is equal to s by m, or omega is s by m under root, and in electrical oscillator this omega square is equal to 1 by LC. So, in this way we can compare the electrical and mechanical oscillators. So, this is analogous relation between both type of oscillators. Now, the further article which we will study is the composition of two perpendicular SHMs, that is composition of two perpendicular simple harmonic motions. In the previous articles, we have studied only single harmonic motion, but in this article we will find the composition, that is the mixed effect of two simple harmonic motions. So, there are two different harmonic oscillators, and the net resultant of the two oscillators is called composition of two harmonic motions. So, we will study this composition in two parts. First part is composition of two perpendicular SHM of same period, time period. And secondly, we will find the composition of two SHMs with the time period of in the ratio of 1:2, that is 1:2 time period ratio. In first case, the time period are same, both t and t, but in second case, if time period is t for first oscillator and time period will be 2t for second oscillator. So, it is the ratio is 1:2 and in the first case ratio is 1:1. So, we will study both articles. So, first we will study the composition of two perpendicular simple harmonic motions having same time period, that is 1:1 ratio or same time period. So, let two simple harmonic motions are written by x and y, where x is equal to any constant a into sine of omega t plus phi and y is equal to a sine of omega t. So, I have assumed that there are two simple harmonic motions are written by x and y. X is equal to a into sine, sine means harmonic function, and y is also consisting of sine, that is harmonic. So, both are harmonic motions. So, I have taken this the constant as a, in the second case the constant as b, and both are sine functions, but there is a difference of phi, there is no phi. So, the phase difference between these two harmonic oscillators is phi. Now, if you combined these two motions x and y, x means along x axis, y means along y axis. So, both are perpendicular because x and y are perpendicular. So, in this way these are two perpendicular simple harmonic motions. Now, we will combine these equations 1 and 2 mathematically. How we can combine it? So, we may solve the equation number 1 and then putting the values from equation number 2 in equation number 1, and finally we will get the combined equation. It is very simple. This x may be written as a into sine a plus b. It is sine a cos b plus cos a sine b. Is it clear? Because we know the formula sine a plus b is equal to sine a cos b plus cos a sine b. And further, this sine omega t is y upon p. So, we will put the value of sine omega t from the second equation. So, we will use this second equation in this first equation, and finally we got the third equation, combined equation. So, this is sine omega t, but in the second term it is cos omega t, but we have the equation for sine omega t. So, we can convert this cos omega t as 1 minus sine square omega t under root. So, before putting these values, we will prepare these terms as sine omega t is equal to y upon b from second equation number second, and this cos omega t is equal to 1 minus sine square omega t under root. You know this formula, and which is further equal to under root 1 minus, and it is sine square means y square over b square. So, we will put cos omega t as this 1 minus y square upon b square under root and sin omega t as y upon b. And finally, we will get this x is equal to a into sin omega t means y upon b into cos phi, because phi is constant, plus cos omega t, that is square root 1 minus y square upon b square into sin phi, this one. So, This will be written as y upon b into cos phi plus this b square minus y square under root, because we will take LCM, it is b square. So, b square minus y square over b square under root, that is only b, it is sin phi. So, on solving or separating this x and y terms, and we will get on simplification, we will get finally x square upon a square plus y square upon b square and minus 2xy upon ab, x upon a, y upon b, into cos phi is equal to sin square phi, this one. So, this will be the answer which is obtained from equation number 1 and 2 on combining both. So, from this equation we can find this. So, this is final combined equation. So, we will discuss this equation in detail by taking the special cases. So, what are special cases? Special cases are nothing, these are the different values of phi. So, we will consider its special cases. So, what are special cases? Special case means first case when phi is equal to 0 degree. Case number 2 when phi is equal to pi by 4 or 45 degree. Case number 3 when pi is pi by 2, that is 90 degree, and case number 4 when phi is equal to 3 pi by 4. Case number 5 when phi is equal to pi, means 180 degree. So, in this article we will find these 5 cases, means the 5 different values of phi we will use and find the resultant equation. So, you will get the 5 different answers. The first, when phi is 0, first case when phi is equal to 0 degree. So, put the phi as 0 degree, 0 value. So, we will get x square upon a square plus y square upon b square as it is, and minus cos 0, phi 0, cos 0 1, minus x 2 x upon a, y upon b into cos 0 1, and is equal to sin phi, sin 0 0. So, this is equation, or it is complete square of x upon a plus y minus y upon b whole square is equal to 0. This is first minus second a minus b whole square. Or if we take the square root on both sides, we will get 2 types of answer, plus minus x upon a minus y upon b is equal to 0. So, it is nothing, it is the equation of straight line. So, there are 2 equations of straight line because it is linear equation. Why it is linear? Because the power of x as well as y both are 1 1. So, you know that in the equation of straight line the powers of variables x and y are 1 1. So, it is these are the set of 2 linear equations. So, if we plot the graph for x and y, so you will get this type of answer. This one, it is x axis, it is y axis, it is 0, it is minus x axis, and it is minus y axis. So, this is the straight line. So, it is not a single straight line, actually these are the overlapping of 2 straight lines. These 2 straight lines are overlapping on each other. So, you will get this type of answer in the first case. Similarly, we can find second, third, fourth and fifth cases, and we will draw the corresponding figures or shapes, and these figures or shapes which are representing in the graph are called Lesage figures. So, we will discuss the further cases in the next articles. Thank you very much.